Bismillahirrahmanirrahim. This is Sophia Suhail is here. Assalamu alaikum, my dear students. So today's my topic is that what is a derivative? This is very important to understand before doing the differentiation or before applying any rules to solve the question which you need to differentiate. That what is a derivative? Okay, before coming to its definition, you must know about the function y equals to f of x. A function of the form y is equals to f of x, where you must know that x is the independent variable. X is independent variable and y is dependent variable. Dependent variable. So we must know about a function which is dependent on the other value variable. This is independent variable and x is belongings to the domain of the f. Okay, keep this point in the mind that we are dealing with the function which is dependent on another variable. Okay, so y is equals to f of x is a function where y is called dependent variable and x is called independent variable. After that, now we are coming to the proper definition of the derivative. What is a derivative? It is a function. It is also a function. What type of the function it is? It is a function that is describing the slope of a line tangent to a curve. It's a function that is describing the slope of a line tangent to a curve at any point. Now, to understand this statement, you must know that what is called a slope and what is called a tangent. Okay, in a curve, we are not discussing that in a straight line. We are discussing this about the curve at any point. I'm again repeating, what is a derivative? It is a function that is describing the slope of the line tangent to a curve at any point. Okay, and what is the purpose of the derivatives? It's giving us, it's giving the rate of change, rate of change at any instant. Instant means very in this one you must know about the rate and must know about the instant and the change also. A rate, what is the rate? Rate is comparison of two quantities to different quantities. Okay, if you are doing the comparison of change in one quantity with respect to the change in other quantity, that is called a rate. Okay, so we are checking the rate of change at any instant. Means the instant means the very short time, or you can say instantaneous rate of change at any point. I just write down the definition for you to be clear about the definition, and then I will evaluate in graphical formation also to make the concept clear that how we will take a function, how the slope will be taken, how I will go to the tangent line. Okay, taking a curve line and then on a making it to the tangent form. Okay, now I told you that what is a slope. What is the slope? let me explain that slope also. If you are taking any graph, any curve graph, okay, so it's not a straight line, not in horizontal way, not in vertical way. So each and every point, if you are drawing a tangent line, at every point the tangent line is different. Tangent line is different for every point. Means tangent line, what is a tangent line? A line which is touching the given curve at only one point. Suppose I say this is T1, this is, I'm taking T2, this is T3, this is T4, this is T5, and I have taken different tangents. More can also be applied because continuously the curve is continuously, so many tangent you can take at every point. Curve is the combination of all the points. How many points you can take at the same points, tangent can be drawn. As tangent, you have seen is tangent line. As the tangent line I draw is changing. Tangent line is which is I have drawn, it is changing its direction, it's changing. That's why we can say that its derivative is a function. Okay, now what is the purpose of the derivatives? Derivatives are telling us the slope or steepness. This is very important topic. Let me define again what is a derivative. It's a function that is describing the slope of the line tangent to a curve at any point. So it can also be said that it's giving the rate of change at any instant. Instant means very short interval. Okay, very short but countable, existing interval, or instantaneous rate of change at any point. These two are almost same. Okay. So we are taking the tangent line I have defined over here. Now I will do the actual interpretation of the derivation. Let's take a coordinate system. Okay, and I'm just taking any curve. On the curve we have to make a tangent line, but first we will take a secant line. Secant line is touching the curve or cutting in the curve at 2 points. Let's say this is the point A and this is the point B. Okay, so the slope of this line will be equals, slope of this secant line will be equals to, we know that the slope formula is y2 minus y1 over x2 minus x1. Okay, what is y2, y1? The points here for the first point and the second point. Let's take that this is at x, this is x-axis and this is y-axis. And I suppose that y is a function of x. So if I will write down the coordinates of A, the first coordinate is the x because its distance on horizontal axis, and the second coordinate is its distance on the vertical axis, that is y, and y we have supposed as a function of x. Okay, it's looking big because I want to demonstrate that one, but the B point I have taken with a little difference. I just increase the distance of this one about h. What is h? A very small quantity. A very, very small quantity. Okay. So here it is x, here it will become x plus h if I added this distance on horizontal axis. Now I will check, here it was f of x and this distance here it's becoming the same. I have taken this over here and here. So this is becoming x plus h now. After the change in h, this is becoming x plus h, and y is also changed across the position. When x is changing, so there will be a change in the y also according to the same change. So there will be a change in the y coordinate also, so the function will also be changed across f of x plus h. Okay, so this will be the coordinates of the b point. This is the coordinate of a point, this is the coordinate of b point. Now what will be the slope? Y2. What is the y2? Means the second coordinate. This is x1, x1, y1, and this is x2 and y2. Coordinates of the first point and coordinates of the second point. So y2 is f of x plus h minus y1 is f of x divided by x2 means second coordinate of x-axis x plus h minus x. Okay, solving it we will get f of x plus h minus f of x over x plus h minus x. As we can see, they can be cancelled. So f of x plus h minus f of x over h we are getting. Okay, so this is the slope of the secant line. Okay, now we will come to our point. What is the tangent line? How it will be tangent line? Just look at that carefully. If I'm decreasing this distance of h, I'm decreasing this distance and I'm decreasing the value of h approximately equals to 0. How? This is the difference of h, so I'm going to decrease it to a point like this. If I want to find out the distance over here for the slope, so my accurate distance will be, if I'm going to the smallest interval to here, to here, to here, to here, to here, and keep on continuing. So coming to this one means my this secant line, when h is approximately equal to 0, so this secant line will be behaving like the tangent line. Is that okay? Hopefully you understand this point, that I am saying that h should go to 0 now. H should approach to, this is the h value, okay? This is the h value, this much. If it is approaching to 0, if it is approaching to 0, so the line will keep on back. If it is coming here, line will come here. If it is coming here, the line will come here. If it is coming here, line is coming here. H, the value of h is keep on shrinking, okay, keep on decreasing. If it's coming like this one, where h is approaches to 0, okay, where h is approaches to 0, at this point we can say that this is the limit of the secant line. Limit of the secant line when limit h approaches to 0. So this point, the limit of the secant line will become the slope of the tangent at that point. Slope of tangent at that point when limit of that h approaches to 0, f of x plus h minus f of x over h. This one we can say when y is a function of x as f bar of x. That is equals to limit h approaches to 0, f of x plus h minus f of x over h. And this is the basic definition of derivation also. How it is being explained again, how it can be explained again that a rate of change of two quantities or instantaneous rate of change at any point. Suppose you are checking the instantaneous rate of change at the point A here, okay? Here, when the slope is going too small and secant line is approaching to a tangent line. When h is approaches to 0, and there is a condition that the limit of h approaches to 0 must exist. Limit h approaches to 0 should exist. Okay, hopefully you understand the different derivation of this form which is used for finding the derivative. This formula is called, which is used for the derivation of by the first principle also, and this is original definition of the derivative also. So hopefully if you like my video, so please subscribe to my channel. In the next I will explain the power rule also, I will drive that also. So until then, thank you so much. Allah Hafiz.